Today we're going to look at how you go from a word problem and create a graph from that word problem. Our first step is to make sure we understand the word problem. So imagine you're going into a yoga class at a fitness center, and at that fitness center they're going to charge you $100 just to register for the fitness center. And then every class you go to is going to be $10. So the variable in this case is going to be our lessons. How many lessons are we going to have? We could have 1, we could have 10, we could have none. We really don't know at this point. But we do know that we're going to have to pay $100 regardless of how many lessons we take. So what we can say is that our cost in this case is going to equal the $100 plus $10 for each lesson. And let's call the lessons L in this case. Now normally when we write an algebraic expression, we put the term with the variable first. So I'm just going to rewrite this as 10L plus $100. Once we have our relationship between the cost and the lessons, we can actually create a table of values. So which one depends on the other? Our cost is going to change depending on the number of lessons. So we're going to put the cost over here, and we're going to put the lessons over here. Or we could also think of this as lessons. Our variable is L, and our cost we could call the variable C. Suppose we just walk in and we take no lessons, but we just pay the registration fee. Looking at 0, if we plug that in for the L, so 10 times 0 plus 100, we get a cost that's equal to $100. If we were to take 1 lesson, then we'd take 10 times 1 plus 100 equals 110. 2 lessons and so on. In a linear relationship, we always find that the increases are constant. In this case, going from no lessons to 1 lesson, from 1 lesson to 2 lessons, our increase here is always 1. It doesn't have to be, but we know as we increase by 1 here, we look at our cost goes up by 10 each time. And going up by another 10, it's going to be $120. We can verify this by taking our 2, putting it back into the equation, substituting it in. 2 times 10 is 20, plus 100 is $120. 3 is going to be 130, and so on. Once we have our table of values, we can now take the table of values, and that's going to give us ordered pairs. And we can use those ordered pairs in order to graph. So in the first case, we know that lessons versus cost, we know that if we have no lessons, our cost is 100. If we have 1 lesson, our cost is $110. If we have 2 lessons, we're going to pay $120, and so on. Now, whenever we're graphing a relationship, we want to create an X and a Y. Now, normally these are X and Y. However, in this case, we don't have X and Y. We have our lessons and we have our cost. Our cost depends on the lessons. So the lessons we're going to put on the X axis. So in this case, we're going to call this lessons. And we have a choice for the number of lessons. We could take no lessons. We could have 1 lesson. We could have 2 lessons. We could have 3 lessons, and so on. You'll notice that when I've put the different marks on my x-axis, they are all equally spaced with the interval, the distance between each being the same. 0 to 1, 1 to 2, and each one is actually 2 of the blue marks across. We're going to likewise do the same thing for our y-axis. Our y-axis, however, though, in this case is our actual cost. So we're going to write the word cost on here, often written like this. And our cost is in dollars. Now, when we're working out how much this is going to cost, we have to choose an interval in order to graph the equation. In this case, I'm going to choose an interval because my first zero is up to 100. I need to be up here a bit. So I'm actually going to choose intervals of 20. So this is going to be 20, 40, 60, 80, and so on. It doesn't matter so much the intervals. You want to choose one that works well for you. And as we're graphing this, we can use our ordered pairs in order to create the graph. So looking at our first one, our x value, x is first in the alphabet, so the x always comes first, or the y, or in this case we are using our lessons and our cost. You could look at it in any of these ways. So our x value in this case is 0, our y value is 100, so we're going to go from 0 up to 100. And we want to label that point so there's no confusion about which point we mean. At 1, we go from 1 to 110, which is about halfway. At 2 to 120. At 3, we're going to go up to 130, and so on. Now, looking at my graph, I can see that this would form a straight line going through. So we say that this is a linear relationship, because the relationship between our lessons and our cost forms a straight line. The last thing I want to mention is we can't really do half a lesson. So we're not going to create a line in between these because there's no way we're going to take half of a lesson and pay $5 for that half of a lesson. We have to assume that the fitness center is going to have full lessons. So in a case like this, we just create the marks for each spot and we actually graph each of those marks. We can then use our actual equation to figure out if we had $200, how many lessons could we take, by simply putting 200 into our cost is equal to 100 plus 10L. And we could actually solve for L and find out how many lessons we could take. So we can use our initial equation to help us create a table of values. From the table of values, we can get ordered pairs. From the ordered pairs, we can come up with a graph. From the graph, we can either look at the graph and read the graph to find out the answer to a question like $200, how many lessons can we take? Or we can actually substitute the value back in to the equation and then use the equation to find the answer. So algebra lets us ask a lot of questions and to be able to answer a lot of questions. I hope this has been helpful.